Why is the sky blue? We're jumping right into it today. You look up on a clear afternoon and you just see this brilliant, endless blue canvas stretching out forever. It's such an everyday thing, but in this explainer, we're going to dissect exactly how the sky actually gets that magnificent color.
Have you ever just stood outside, looked straight up, and genuinely wondered to yourself, why is the sky blue? I mean, it feels like such a basic, almost childlike question, right? Because it's literally right there in front of us every single day. But it's actually a pretty profound scientific reality hiding in plain sight. And figuring out the answer, well, it takes us on this fantastic myth-busting journey into the physical realities of our planet.
Okay, so it's incredibly easy to just kind of assume that the sky essentially has its own permanent color, almost like it's painted onto a ceiling. But the reality is remarkably different. The sky actually doesn't have a color of its own at all. No way, right? That breathtaking blue is really the direct result of this massive, continuous interaction between sunlight and the Earth's atmosphere. It's an everyday optical marvel happening constantly on a planetary scale.
The anatomy of sunlight. So, to really understand the sky, we've got to first understand the light that's illuminating it. We need to unmask the very anatomy of sunlight itself. Why? Because, frankly, our eyes are playing a little bit of a trick on us. Think about it. When sunlight bounces off a white piece of paper or, shines down on the sidewalk, it just looks pure white to us, doesn't it? But actually, scratch that. That white light is a tightly packed bundle of hidden information. 100% of that white sunlight is made up of literally all the colors of the rainbow. You've got red, orange, yellow, green, blue, indigo, and violet, the whole shebang. They are all traveling together, perfectly blended into a single, seamless beam of white light. The Great Collision. So that perfectly blended white light, it doesn't stay that way forever. Just imagine that light blasting out from the sun, hurtling through the completely empty vacuum of deep space for millions of miles in total, uninterrupted silence. And then, suddenly, bam! It smashes right into the invisible shield of our planet.
Let's break down exactly what happens during this chaotic, microscopic collision taking place miles above our heads. Step 1, that tightly packed bundle of rainbow sunlight finally enters the Earth's atmosphere. Step 2, well, it's not traveling through an empty vacuum anymore, is it? It violently collides with trillions of tiny, invisible molecules of air. And step 3, this physical collision causes the light to literally break apart. And here's the kicker. It causes the blue light to scatter wildly in absolutely every direction. But wait, why blue? Why doesn't the sky look green or red during the middle of the day? Well, it all comes down to the actual shape of the light wave. See, blue light travels in a much shorter wavelength. And because it's shorter, it hits those air molecules and gets bounced and scattered everywhere, almost like a hyperactive pinball. This microscopic pinball effect is a real thing. It's actually known as Rayleigh scattering. Meanwhile, the red and orange light, they have a different, longer wavelength. And because of that extra length, they just scatter a whole lot less. So when you look up, your eyes are being constantly bombarded by that highly scattered blue light just raining down from every conceivable angle. And that is what makes the entire sky appear blue.
This sunset shift. Now let's test this logic together. I want to challenge you to apply this new rule we just learned to a totally new scenario. If the sky is filled with all this scattered blue light during the day because those short wavelengths are violently hitting the atmosphere straight overhead, what exactly happens when the sun starts to go down? What actually triggers that incredible color change of the sunset?
Think about it. At sunrise and sunset, the sun is sitting way low on the horizon. This means the sunlight has to travel horizontally through so much more of the Earth's atmosphere just to reach your eyes, way more than when it's directly above you at noon. And because it has to travel through all that extra air, almost all of that short wavelength blue light gets completely scattered away before it even reaches you. It is literally entirely filtered out. So what actually makes it through that long, dense atmospheric journey? You guessed it, only the longer wavelengths. The reds, the oranges, and the pinks are left basically untouched to totally dominate the evening sky.
I absolutely love this quote from our source material. Sometimes the simplest questions have the most fascinating answers. It really just perfectly captures the essence of what we've unpacked today. The next time you look up at a bright blue sky, you're not just going to see a static blue ceiling. You'll know for sure that the sky itself isn't blue at all. You are actually looking at this incredibly active, dynamic filter, our Earth's atmosphere, scattering the hidden blue waves of sunlight straight into your eyes. It's a real game changer when you think about it. And it really makes you stop and think about everything else in our daily lives that we just take for granted. I mean, if the blue sky is just this magnificent optical trick of the atmosphere playing with sunlight,
What other simple, everyday wonders are hiding fascinating scientific truths right above our heads, just waiting for us to ask the right questions? So keep looking up, keep asking why, and thank you so much for joining me in this explainer.